Hi everyone. Back in section 0.14, we talked about a classic problem with lines. Given two distinct points in the xy plane, find an equation for the line containing those points. Now, how many distinct points in the plane will determine a vertical parabola? 3. So, given 3 distinct points, find the equation of the parabola, the vertical parabola, that connects the 3 points. Now, bear in mind, the 3 points have to be non-collinear. Not only do they have to be distinct, they have to be non-collinear, meaning that they cannot lie on a straight line. There's no way that these 3 points will determine a parabola. Now, for the general problem involving 3 non-collinear points in the plane, you may have to solve a system of 3 linear equations in 3 unknowns using matrices, perhaps. That's chapter 8. But it would be very convenient if one of these 3 points were known to be the what of the parabola. If one of these 3 points were known to be the vertex of the parabola, V. In which case, in order to determine a vertical parabola, we would just need one other point in addition to the vertex. Because remember, since there's an axis of symmetry, there's an implicit third point over here that's given for free. So if we know the vertex and one other point on the parabola, then again, we can get a third point by exploiting symmetry, but we don't even need that third point when we do the calculations. Instead of going through some complicated thing with descending powers form, instead of having to deal with matrices, we can deal with the vertex form. Y equals a times the square of x minus h plus k. Once again, what do students forget? They often forget the square. They forget it's a quadratic, in part because they're so proud when they write x minus h in parentheses, they forget the square. Don't forget the square. Example. Find an equation for the parabola, the vertical parabola, that has vertex 4, 2, and that contains the point 1, 29. So if you go to Desmos, all right, well, we're claiming that we need a parabola with vertex 4, 2, all right, 4, 2, that's right there. Now, we want this parabola to go through the point 1, 29. I don't see 29 in this y-axis, so I think we're going to need unequal axes in this case. So let's go to the wrench over here in the upper right. For y-axis, instead of from about -8 to +8, why don't we go from about -10 to +40, let's say. If you want, you could change the step size and have things where the tick marks are by 5s, the number tick marks, but we can stay by 10 for now. All right. We can add labels also, put y here and x here. We really should do that, actually. Label the axes. We really should do that. Okay. So where's the point 1, 29? Right there. I want the vertical parabola that has 4, 2 as the vertex, and that passes through 1, 29. This parabola is going to open how? Well, it's got to open up if it's a vertical parabola. So let's find the parabola that connects these dots with 4, 2 as the vertex. Okay, so here's vertex form. Well, I'm telling you what the vertex is. It's 4, 2. H equals 4, k equals 2. So you can plug these in for h and k. So h equals 4. We still have the minus sign in front. K equals 2. So we have y equals a times the square of x minus 4, all plus 2. Now, we have values for 2 of the 3 unknown parameters, h and k. We now need to know the value for a. So how can we solve for a? There's another piece of information we can use up here. The fact that the point 1, 29 has to lie in the parabola. Remember the basic principle of graphing. The graph of an equation consists of all points whose coordinates satisfy the equation. So in order for this point to be on the parabola, x equals 1 and y equals 29 must satisfy this equation. Let's plug those values in. Plug in x equals 1, plug in y equals 29, right? And we get this over here. X equals 1, y equals 29. And now we can solve for a. 1 minus 4 is negative 3. The square of negative 3 is 9. So we get 29 equals 9a plus 2. If you had forgotten the square, you'd have had negative 3a. Don't forget the square. Okay, let's subtract 2 from both sides. We get 27 equals 9a. So a is what? Dividing both sides by 9, a equals 3. Again, a does not have to be integer, but here it is. We're not done yet. What do we have to do? We have to take this value for a, and just like with y equals mx plus b, just like with those variation problems from 0.16, you have to plug this in. Back to here. Remember, we now know h, we now know k, and now we know a. We can plug in 3 for a. And then from here, we get our final equation in vertex form. Y equals, remember, a equals 3 times the square of, don't forget the square, the square of x minus 4, all that plus 2. Well, let's see if this works. Y equals 3 times x minus 4 all squared, all that plus 2. Yes, it does. Notice that 4 comma 2 is the vertex over here, and it passes through the point 1 comma 29 over here. Vertex of 4, 2 goes through 129. I guess it's good to flash the labels. And of course, it opens upward. A equals 3, which is positive. Very good. So we've done our modeling problem. All right. After this, what happens if we go beyond quadratics and parabolas?